Thank you very much for the introduction, Chairman.
Okay.
Thank you very much for the organizers for this great event. Maybe I can use the...
Okay.
Thank you. For this great event, and I'm looking really forward for the next 2 days in networking and talking, exchange informations and experience, of course. And a last big thank you to my colleagues from Turkey, who invited me for this event this week and for this opportunity to have the speech or this moment here to talk to you about one of our solutions, or more or less, let's say it another way around. We heard in the previous speeches a lot about the challenges in the market, and I want to talk about one possible solution or one tool to support the market to reach the future goals or to solve some challenges in the future. So today I want to talk about AI using for operation support in the cement industry. But at first, because not everyone maybe knows us, we are Innomotics, a Siemens business. So in the former years, or in the last years, historical-wise, we was named LDA, so Large Drive Applications. And now we are a new kid on the block, let's say it in this way. We are formed as a new business company named Innomotics. But what does it mean in the end? And it means transferring experience for 150 years in motors and drives, in automatization technologies, and electrification technologies, into a new company, carve them out from this big Siemens ship, let's say it in this way, and to make it more flexible, more faster, and closer to the market. So in the end, for the markets, nothing changed. It's only a new color, maybe a new name. If you like the yellow or not, it doesn't matter. But we are more or less the same company like before, but we are now, hopefully in the future, closer to the market to fulfill and to help you with all your problems, especially in electrifications and automatization. So in the end, in a nutshell, to give it an overview, we are 3 to 4 billion big company in turnover. We are placed in 49 countries with 16 factories worldwide, and we are more than 50,000 employees. And like you see here on the map, in the end, we are spread all over the world. So also in Turkey, we have a huge facility here. We are here with a booth, so upfront, I want to invite you for the next day coming there and asking questions about the portfolio and our solutions in the end. So you see, we are a global player. And what is our portfolio in the end? I will do it really fast because I'm not the motors and drives expert. We have more or less the complete portfolio of everything what you need for electrifications. Means low voltage motors, medium voltage drives, high voltage motors. Then we have 2 special departments. So one is solutions business. I will jump more into detail later on. And we have the CS, the service, for keep the systems running in the end. So really, really fast going through the portfolio, our low voltage motors. And of course, then we have our flagships, our medium voltage drives, which often are really, really, really known in the market. And then, of course, our biggest motors. So we are moving also the biggest machines in the world, especially, and this is something what I was mentioned on the slide before also, especially for the heavy-duty industry. So we have a strong focus in mining industry and, of course, in cement industry, steel industry, gas and oil, and so on. So therefore, we are using our complete portfolio and integrating it into the market, into our customers. So in this business, Innomotics, in this company Innomotics, there's a specialized vertical, which is called solutions or minerals, which is really special or focused for the minerals in the cement market. So here, I give you a more dedicated overview about our solutions for this business. You see, of course, on the left side, our material handling solutions from the mining environment. Then you see our flagships, the big grinding mills, so our GMDs, for example. We had a lot of experience in automatization systems. And on top now, we started developing 5-6 years ago digitalization portfolio. This digitalization portfolio is more or less covering the complete process from pit to port in the end, with different possibilities of using technologies in a digitalization environment. It means manufacturing execution systems, operations support, maintenance support. So we try to cover every aspect of digitalization for the future in this industry. A special thing here to mention is it's not directly linked to our hardware portfolio. So it means you not have to buy a Siemens motor or drive to use our digitalization solutions. These solutions are vendor-free. That does not mean please buy our motors and drives, but in the brownfield activity, of course, we can do a retrofit with our digital solutions, and it doesn't matter which hardware is installed there. So you see here, we have a strong foundation, a long history in motors and drives, in electrification and in automatization systems. And this is something what a lot of you, I think, knew from the past. Of course, our PCS7 automatization system, which is really often installed globally in cement plants. Here standing about over 1,000 installations. We are talking about 40%, 50% market share in this automatization solution. And there's a special type dedicated for the cement industry, which is called CEMAT. And this is really often given in the industry. And this was more or less the foundation to create, or to ask more or less what's the future. And we jumped into a digitalization. So we are coming from a huge experience in the past in automatization system and process intelligence or knowledge about cement production, and then started developing a digital solution specified for the cement industry. And this is something that we not did alone, because we more or less are trying to develop our solutions together with the customer. So this in the end a customized solution, and we started together with a plant in Hungary. The company name I'm not allowed to say, but it's a global player. And they come to us more or less with the request to say, okay, we have some problems. We have a leakage of resources, of experienced operator. We have these challenges, what we heard in the presentations before. Can we do something for optimizing our production? And then the story starts. We tried it with an AI, implementing it into the system of the production of the cement customer, and we reached great results. And this is what I now want to talk. The second part of my speech about this technology, what we did there and how it works. And in the end gives you some result numbers to get a glimpse what is the benefit of it in the end. So what we tackled, or what was the goal from the beginning on, again, we heard a lot about challenges, and this is something what of course we also try to tackle or to solve. So in the end, we want to optimize the production, lower the costs for fuels, lower down the CO2 emissions, harmonizing the production, avoiding min and max situations, avoiding unplanned downtimes, avoiding clogging. So really covering the complete heart of a cement production means for us pyro process. So from the preheater over the kiln to the cooler, and try to support the operators there really to come in really static and harmonized production in the end. And this was our task, our goal, and then we decided to develop a digital solution. And this digital solution is not only using AI software or catching some data and doing some analysis and give some informations. No, it's a platform system which is completely customized and integrated to the end customer in the end. So there's nothing a system. There's no edge computing. So we are not taking the data to our system or to a cloud system or somewhere else, doing there some stuff and giving you back the information. No, we really developing together with the customer for the requirements a system and implementing on-site, on-premise, or in the cloud system from our end customers. So the data is not leaving your plant. That's the first thing. So this software system is installed on a server, on a cloud, like I mentioned, and has several modules. In these several modules, we are not only doing analysis, we're also creating reports, making dashboards. So you see there are several functionality blocks who helps you for raising up transparency of your production, raising up the transparency of maintenance, effectiveness, and so on and so on. So this is all in there, included, and then we developed three different AI modules for optimize, or more or less for operational support. These three modules one is for the mills, so it's specified for the mills. I show later on some results. We have one for the kiln, and we have one which is covering the complete pyro process, so the heart of the production. Means, like I mentioned before, preheater, kiln, and the cooler. The pyro process AI more or less comes from the point that we started developing a solution for alternative fuels production or usage as a fuel. And then we realized after a while it's not only possible to cover the kiln when you use RDFs, so in the end we have to take into account the complete section in the end. So, and this is, more or less, this was our starting point to say, okay, the pyro process underlies a huge complexity. So we have thousands of data points, of course, but there are some process values. I think we are using 35 process values in the end, what we have to cover in our system, who more or less gives an indication how the system is running to the operator. And from there, the operator is deciding what to do. I think this is clear for you. So in the end, we try to copy it in a virtual environment. So we are using the same data in a 1 second frequency and pushing it into our system, and then starting analyzing the data and giving a forecast. This was the first idea. So the forecast means what happens in 15 to 30 minutes from now. So, and from this information point, we started in a next step. I will go a little bit deeper on the next slide, to give recommendations. So not only doing a forecast with thresholdings and say, okay, this will happen, have a look into your data in the end. So really, we give you a trend, and then later on give you an analysis and then a recommendation in several steps, how to react, how to solve challenges which are coming in front of you, how you can better operate your kiln in the end. And this works in a multi-layer AI approach. Okay, big word, but in the end it's not so complex. So we are taking the data from the past, if you have an historian, and we are using the actual data, putting it into our servers, and then starting, let's say, a correlation via machine learning. This is the first step. So it means we are searching for patterns in the past based on actual values, and then giving you the forecast. This was the first step, what I was described before. After this, with this forecast, we're going into the next AI loop, let's say in this way. So in this next AI loop, we are using a neural network for also take into account not only the forecast values and what happens in the past and what is the current situation, we also take into account what are the limitations, the physical limitations. So for example, you are not able to change random things to avoid problems in the future. You have to take into account what is really in the reality possible and what was happening in the past, more or less. And this is what we are doing via a neural network to give you recommendations for your set points. So it means in the end to control it in kiln operation or production, you have more or less 5, 6 set points, 7 set points where you can play with a little bit. And we are giving recommendations for these set points. So in the end, also not only a forecast, here we're coming to the point to say, okay, do this and this, react this in this way to avoid the things which are more or less forecasted. And then in the last step, and this is a little bit new, so it's not completely covered here. We also, in a third AI loop, we are using a fingerprinting model. We call it fingerprinting. So in this fingerprinting, the algorithm, after the forecast and the recommendation for the set points, is searching for several situations in the past in the database. So it's like a filter to have a look, okay, what happens in the past if I do the recommended change. And then is screening more or less the complete knowledge, what means in the end the knowledge of hundreds of operators about the time in your plant in the end, and checking, okay, when I'm doing this, what happens then? Checking what is I'm doing this, what happens then? And then calculating in the end the best optimized way to react with the recommendation from the system. So it means it's not only covering data analysis or covering experience from data perspective, so it also takes into account what happened in the past, because from the data you can see how operators reacted to different situations in the production. And in the end, of course, this system is learning, because with each and every decision you have a new, let's say, picture or reaction in your database, in your historical database. So it's a self-learning system and getting better and better and better. So what was the goal in the end, or what was the result? Here a small graph. Of course, in an operation you always try to keep your operations, your heat more or less in a proper level between a minimum max value and with not going too far to less. So in the end, you can harmonizing it, because when you learn from the past, from all the operators in the past, these decisions, the good and the bad decisions, of course, you can better calculate how to react to several situations. And when you better can react to several situations, of course, you lower the fuel consumption via the same throughput, for example. Of course, it's not so stressful. Of course, you can use younger operators based on the fact that there's a system which is more or less has the experience of all the operators before. So in the end, a not so experienced operator can also operate the system from the beginning on easier based on the support of the solution in the end. And of course, there are a lot of side effects which are not directly measurable after such a short time. The influence of bigger maintenance cycles, for example, based on the fact that you're not stressing the kiln so often, and so on and so on. So in the end, it's a huge impact to your production in the everyday work. So I mentioned it before. We have two different solutions. So the AI for the mill and the AI for the pyro process. And these are some results which are proven from a customer in India. It's Wonder Cement in the north of India, which is using the mill. And we see here that, of course, the production was higher via the same input. It's interesting, and because based on the fact that the throughput or the output as product was bigger than before by the same input, of course, then it lowers the energy consumption. And this was here about, I think, 3.5%, for example. And this gives you a glimpse what is possible with such a solution. And this only works in this moment 25% of the time, based on the fact that there are some technical issues, not on our technology, but on the plant side, because the lab is not connected to the system, and then sometimes the quality values are not directly tracked in the system, but if they're using it, these are the results. And now the customer decides, okay, that's amazing. He was really hesitating in the beginning using such a technology or giving the production heart to AI in the end. And now they more or less give the operators incentives to operate this solution minimal 80% on a workday, because you realize that you really can save money with the solution. And last thing, it's a little bit complex graphic, to be honest. I'm sorry for that. But this is a comparison between what the operator did in the production and what our AI solution recommended in the end. And in this moment, this is it's a plant in Hungary, and the operator was reacting to a situation, say, okay, we need more fossil fuels, so we lower down the alternative fuels to keep our production. So we are talking here about the, hopefully it works. No, not works. We are talking about keeping the feed amount in the end, using more fossil fuels to keep the heat and to save the production via saving the quality values. And our solution supported more or less the decision to say, okay, you can lower down the fossil fuels. It's not necessary. You can use more alternative fuels. That's pretty easy to do. And this more or less was tested several months long with a customer, all these decisions more or less, and he proved us until now that our system is working proper in this moment. So in the end, this is only one example of one positive aspect when using such a technology, is really that in this complexity, of course the operator is using more fossil fuels because he wants to be safe that the production is working in a proper way. Because in the end, he has to be, he is responsible for it. But in this reaction, we can optimize the reaction again. And here, of course, you can use more alternative fuels, saving coal or oil or gas, and then in the end lower again your costs for the fuels in the end. That's only one of the examples. What I missed to mention, and this is my more or less maybe last sentence, is that one really new development in the solution was also that we're not only forecasting process values, we also now forecasting quality values. Means free lime and alit. And for us it was really important to also include this forecasting of the quality values, because the end decision about the production in the end is done by the lab and by the quality values in the end. And with forecasting it, we give a little bit more the safety when you see, okay, this is the forecast, this is the recommendation, and you will keep this and this quality. This gives a more safety feeling for the operator to say, okay, we are using the recommendation because we are keeping the quality, so it's fine. And this is, we did it by a retrofitting, of course, it's somehow longer to explain, but we reached an accuracy of the free lime and alit prediction over 95% of the cases. So this is new, this is a huge addition for us, and the customer is, or the customers are really liking it. So, in the end, again, I want to invite you to our booth here, to talk to our colleagues here in the region about our different solutions, our possibilities. I'm really looking forward to answer questions and anything else. And in the end, I wish you 2 nice days in this wonderful place, and thank you for your attention.
Thank you. Danke schön.
Danke.